Hello, ladies and gentlemen. Welcome to Math 20-2, Chapter 3, Trigonometry, Lesson 4, Solving Problems Using Acute Triangles. Now, the goal today is to be able to solve problems using Pythagorean theory, sine law, cosine law, and of course, the standard trig ratio, sine, cosine, tangent. Now, the outcome, we're going to solve a contextual problem that involves more than one triangle, more than one. So this is the nastiness. So here we go. Two security cameras in a museum must be adjusted to monitor a new display of fossils. The cameras are mounted 6 meters above the floor, directly across from each other on opposite walls. The walls are 12 meters apart. The top of the display is 1.5 meters above the floor. Distance from the camera on the left to the top of the display is 4.8 meters. Both cameras must aim at the center of the top of the display. Now, there's the display you're looking at. You don't want to get stolen. Here's the question. What's the angle of depression for each camera? Now, this is a tough question until I give you the picture to go with it. And then you're going, oh, this isn't as bad. It just hurts a lot. Because if I was nasty and evil, I'd make you draw the picture first, and that would just hurt. So we're looking for the angle of depression. That's going down. So one camera, calling it angle theta. The other one is angle alpha. Greek letters. Now, how do we find those two angles? Well, what you've got here is a bunch of triangles, and I want you to look at them. I'm going to color code them. You've got one nice right angle triangle here. Okay. And we have one right angle triangle here. Okay, now that one's a little icky, so let's change color on that. Make it red, because I can. Color coding is always so much easier. There we go. Now, you've got the black triangle and the red triangle. Now, notice they're both right angle triangles. So, what's the easiest one to solve? Well, I think it's angle theta by angle A, because what have you got? A right angle triangle, and you have two of the sides. This is the opposite, and you have the hypotenuse. You don't have the adjacent. Now, when I go opposite hypotenuse in a right angle triangle, first thing that pops in your mind, sine of theta is opposite for hypotenuse. So sine of theta, or sine, is the opposite, 4.5 divided by 4.8. So angle theta is sine of minus 1 of 4.5 over 4.8. So you grab Mr. Calculator. You double check to make certain it's in degree mode. And it is. Inverse sine 4.5 divided by 4.8 is 69.6 degrees. Okay. Now. Okay. So that's the easy one. Now, how do we find angle alpha, the red angle, by angle B? You notice here, I gave you some side lengths. We have, for angle alpha, this is the opposite side. We don't know the hypotenuse, but we have a chunk of the adjacent. Now, the trouble is, we know the entire length there is 12, but we need 12 minus this x, which is the adjacent on angle theta. Okay. Now, since I happen to know the opposite and the hypotenuse for angle theta, or the black triangle, I can use either one of them to help me with the adjacent. I feel like, I'll code this one, find the adjacent here. I'm going to use tan because I can. I haven't done tan in opposite over adjacent. I haven't used that in a while. Now looking for the side length, it's opposite, it's adjacent, tan theta. The opposite is 4.5. Tan of 69.6. Actually, wouldn't it be easier to use Mr. Pythagorean? It would be. Actually, we should, but since I've already started this and I'm making too many dumb mistakes, I'm just going to keep on doing it this way because I can. So 4.5 divided by tan of my answer, close brackets in case calculator likes it, 1.67. Now, I can hear several of you going, but Mr. Sutton, we calculated the angle 69.6. We shouldn't use it just in case we made a boo-boo. We should use Pythagorean's theorem here to solve for it. And you're right, but I'm old and I forgot that. So just double checking because I can. This is going to be a squared plus b squared equals c squared, or 4.8 squared minus 4.6 squared. Squared is 1.88. The square root of my answer is 1.37. 0.37. Oh, 4.5. God help me. 4.5. Read the question, Mr. Sutton. 2.79. Square root of my answer. 1.67. So if I put in the numbers correctly, yeah, it should still work. But I shouldn't have done it that way. So anyway. Now, this is 1.67, so this adjacent is going to be 12 minus 1.67. $10.33. So now I'm looking for the angle when I have the adjacent and the opposite. So this is tan of theta again. The opposite is 4.5. The adjacent is 10.33. Angle theta is 10 minus 1, 4.5, 10.33. That becomes 23.5. Okay. See how that goes? So the whole idea here is we have multiple triangles. And we solve for one and use that information to help solve another. So, right? And once again, take a quick look at our drawing. If you make the drawing relatively to scale, you're going, oh yeah, 23.5 and 69.6 are reasonable answers. Now moving on. Now, while visiting the park, Manuel wanted to determine the height of the totem pole, so he drew a sketch and made some measurements. I walked along the shadow of the totem pole and I counted 42 paces, estimating each pace was about 1 meter. I estimated that the angle of elevation of the sun was about 40 degrees, and I observed that the shadow ran uphill, and I estimated the angle that the hill made with the horizon was about 5 degrees. So here's his drawing here. See, we have the ground here. It's going up at about 5 degrees. The shadow is about 42 meters long, and the angle of elevation he estimated was about 40 degrees from the ground. So the question is, how can Manuel determine the height of the totem pole to the nearest meter? Let's solve for height here. Now, once again, we've got a couple of triangles here. We've got this one here, which is useful. Well, we've got one side of it and an angle, but we need a second side or a second angle. But note, we have a second triangle here. Now, with that second triangle, what have we got? Well, I'm going to use the second triangle first to figure out some angles and sides. So let's move this here. It makes it a little messy. So for the black triangle here, this is a right angle. Now, can we figure out anything else about it? Well, yes, we can. Because, oh, sorry, we actually have a third triangle here. I'm sorry. Let me show you. Down here. So we actually have 3 triangles we have to work on. Make this one orange to be different. Oh, you bok cha. And I meant that. So, make that a little small. Okay, I won't make that a little smaller. God bless my discretion. I can't. No, I can't. All right. There it is. Now, remember 5 degrees here. Now, the other thing I want to point out is the 40 degrees here. So this is a straight line, which makes these two angles supplementary. So this other angle here will be 180 minus 40, or 140 degrees. Now the three angles in a triangle make 180. So 180. Oh, you bok chock, come on. Stop doing that, people are watching. 180 minus 140 minus 5 is 35 degrees. So this angle here is 35 degrees. Now, why do I care about that? Well, since this is the right angle, what's this angle up here? Yes, it's going to be 180 minus 90 minus 35, which is, come on, 55 degrees. Okay, so this is 55 degrees. Now, I have a side, the angle opposite it. I have another angle, 40 degrees, and I'm looking for the side opposite that. What do I use? Sine law. Now, I'm looking for the side length, so that should be A over sine A equals B over sine B. I write the angle down below. So my height divided by sine of 40 degrees equals 42 meters divided by sine of 55. So height is 42 sine 40 divided by sine of 55. So 42 sine 40, close bracket, divided by sine 55, close bracket. 32.95. 0.96 meters. And I believe the question was to the nearest meter? Yes. So rounding that off, that's 33 meters. Okay. Now, annoying? Yes. Complicated? Chunk it. Break it into little pieces and work on it, and it's not bad. But yeah, it's a lot of pieces. A lot of steps there. You can make it really stupid math boo-boo. So, that's it for the first part. If you're having problems with this, watch the video again. We'll talk about it, or send me an email, or we'll talk about it in class. Otherwise, good luck. Let's go on to the next part of this acute triangle problem. Good luck. Good luck.